So they tell us it's a geometric sequence, and it gives us this information about it. And it wants us to find the general term. So once again, if you look in your book, you can find the general term. So it's un equals u1r to the n minus 1. All right. So once again, this is similar. We did a similar problem when we were talking about arithmetic sequences. So we're just going to set up like u2 equals u1r, and then we know our n is 2 for this one, so 2 minus 1. But instead of writing u2, we will write the value for u2, which was negative 6. Do the same thing here. We're going to write 162. We don't know u1, we don't know r, but we know that our n is 5, so 5 minus 1. Alright, so we'll simplify just a little bit. So this becomes negative 6 equals u1 r to the 1. Don't need, I guess, let's write it. And then 162 equals u1 r to the 4. Okay. Now, what we need to do is we need to solve for one of those pieces in each of them. So I'm going to solve for u1. So I just divide both of these by the r. So this one just divide by r, this one divide by r to the 4th, r to the 4th. So we get negative 6 over r equals u1, and we get 162 over r to the 4th equals u1. Since both of these equal the same thing, that means they equal each other. So we can say negative 6 over r equals 162 over r to the 4th. And we can break up the fraction by multiplying both sides by r to the 4th. So it cancels here. We're left with 162. Right here, this is like r to the 1, so we subtract, so it's really negative 6 r cubed. And then we can multiply or divide both sides by negative 6. And so we get r cubed equals 162 divided by negative 6. We end up with negative 27. And if we cube root both sides, r equals negative 3. Okay. So we're trying to find the general term. So we found our r, so we still need to find our u. So I'm going to come up here and plug it in. So negative 6 over negative 3 equals u1. I just plugged in a negative 3 for this r. Negatives would cancel, and 6 divided by 3 is 2. And so we have the pieces that we need for that general term formula, which was right here. And we will just replace it using the stuff we have right here. So I'm going to come back up here and use these two pieces with it. And so I'm just going to say u sub n equals u sub 1, which is 2, times r, which is negative 3, and then n minus 1. And that is our general term formula for that one. Okay. And we have one more example, example 10. Find the first term of the sequence, 6 root 2, 12 root 2, which exceeds 1400. So we want the first term that is greater than 1400. So we know our u1 is equal to 6. We know our r is equal to root 2. Because if we multiply this by root 2, we get this. If we multiply this by root 2, that will turn this into a 2, because root 2 times 2 is just 2. 2 times 6 is 12. So once we recognize that, it's not too bad. Then we use our nth term formula again, like that. Plug it in. So 6 times root 2 n minus 1. And we want it to be greater than 1400. And so we're going to find the n value at 1400. So I'm just going to say 1400 equals 6 root 2 n minus 1. And we want to solve. We want to solve this. Now, since we haven't talked about the algebra, how to do this algebraically yet, we will do it with a calculator. So to do that, we're going to go to here. We're going to graph both sides. So we have 1400. And we have 6 parenthesis second root 2 and raise that to the x minus 1. So make sure you put your exponent in parentheses, because your calculator will interpret it different if you don't. Now we're going to graph this, but we're going to have to fix the window because 1400 is not going to show up. So we go to window. We want to make sure we can see on the y-axis 1400. So I'm going to say 1500 for my max, and then regraph it. So there's our line for 1400. And then we really just need to see where they cross each other. And we see that right here we need to go out further as well. So once again, go to the window. This time our x max needs to be more, so let's just try 1000 to see if it's on there. We may have to change it again, but it's just kind of a guess and check thing. Still thinking. Okay, I didn't like that one. So 1000 was too much. So let's try 100. Okay. And we just need to see where they cross, so we're going to use that same intersect function. Click the first curve, click the second curve, and then we're going to guess. I know it's hard to see, but there's our thing. So I'm going to guess right there. Okay, so the number it gave us is 16.7. Now, at 16, we won't reach this yet. At 17, we'll go past this. And so it wants to know the first value, and our n values have to be natural numbers. And so 17 is the first time we're above it. Okay, so if you need additional help, come to Math Lab. But for now, calculator.